You know that feeling when you pour a perfect glass of crisp white wine? The color is just so vibrant, the aroma is incredible. It's just a beautiful thing. But have you ever stopped to wonder what keeps it that way? And more importantly, what can make it go so wrong? Well, we're going to dive into the pretty surprising science behind all of it. Right, so here we have the tale of two wines. On one side, you've got perfection in a glass. It's bright, it's alive, it's just bursting with flavor. And then you've got the other one, a wine that's prematurely aged. It's lost all its sparkle, it's turned this kind of dull brown, and the taste is just flat. Honestly, it's a winemaker's absolute worst nightmare. So the villain in this story actually has a name, oxidation. And you've seen it before. It's the exact same chemical reaction that turns a sliced apple brown. When a delicate white wine gets exposed to too much oxygen over time, it just breaks down. It destroys everything that makes that wine so special in the first place. But here's the crazy part. What if the cure for this problem was actually more oxygen? I know, it sounds completely backward. What if the secret was to hit the wine with a huge blast of oxygen right at the very beginning? Just stick with me here. This brings us to this, totally counterintuitive idea of fighting oxygen with oxygen. We're going to break down how this seemingly insane technique actually creates a more stable, more beautiful wine at the end of the day. Okay, so the official term for this whole process is hyperoxygenation. It's a really specific technique where winemakers intentionally, and I mean intentionally, blast pure oxygen into the grape juice. And this isn't just any grape juice, it's what's called must. The key here is that they do it before any fermentation even starts. This isn't some slow leak, it's a deliberate, controlled shock to the system. So how in the world does this work? Well, the best way to think about it is like controlled rusting. See, the grape must is full of these things called polyphenols. They're just natural chemicals from the grape skins and seeds. Some of them are totally stable, but others are super unstable. They're the little troublemakers that are going to react with oxygen later and ruin the wine. So hyperoxygenation forces all those unstable, rust-prone bits to oxidize immediately, all at once. And the process itself? It's actually pretty straightforward. First, you press the grapes into must. Simple enough. Second, you hit it with that big, controlled blast of oxygen. This makes all those unstable compounds clump together and just fall to the bottom as sediment. Then you just remove that sediment, and what you're left with is a purified must, all ready for fermentation, totally free of the very things that could have wrecked it later on. Now, this isn't just some cool theory, it is absolutely backed by science. So let's take a look at the research that put this exact technique to the test. So, researchers took fresh must from a bunch of classic white grape varieties. We're talking Riesling, Sauvignon, all the good stuff, and each of them has its own unique chemical profile. They really wanted to see how each one would react to this super aggressive oxygen treatment. The big question they were trying to answer was pretty clear. Could this pre-fermentation shock treatment actually work? Could it get rid of all the bad stuff without harming the good stuff, and ultimately lead to a better, longer-lasting wine? All right, let's get to the good part, the results. Let's see what the data actually showed. Okay, now this chart is absolutely key. It shows exactly what happened to those unstable compounds we were talking about. See the blue bars? That's the must after hyperoxygenation. Look at that, a massive drop right across the board. The technique basically sought out and eliminated all the bad actors that cause that browning and those gross off flavors. It worked. And here's the other really fascinating part, the speed. This graph shows the oxygen level in the must over time. You can see it just plummets. The oxygen they inject gets consumed almost instantly. The entire chemical reaction is over and done within like 30 to 45 minutes. That's it. It's an incredibly fast and super efficient process. And, this isn't just some interesting chemistry happening in a tiny beaker. The principles they discovered in the lab, what you see in the graphs there, are being applied directly on an industrial scale in wineries, inside massive tanks, just like the one you see here. This is science that directly impacts the quality of the wine you drink. So, what does this all mean for the actual wine that ends up in your glass? What are the real-world benefits of this crazy oxygen paradox? Well, the benefits are pretty significant. First, because those unstable compounds are gone, the final wine has way better color stability. It resists turning brown. It also helps preserve all those delicate, fruity, floral aromas that we love in white wine. It even gets rid of some of those harsh, bitter-tasting compounds. But the big takeaway, the whole point, it creates a wine that is just fundamentally more stable and has a much longer shelf life. And hey, don't just take my word for it. The researchers themselves concluded that the amazing results they saw in the lab were confirmed in real-world winemaking. So this isn't a fluke. It's a proven, effective technique for improving the quality and longevity of white wines. So, the next time you pour a beautiful, crisp glass of Sauvignon Blanc, just take a second. Appreciate its stability, that vibrant aroma. And maybe, just maybe, you'll wonder if its perfection is all thanks to a secret, paradoxical blast of its own worst enemy, oxygen.